My screen is visible. Hope my screen is visible now.
Yes, ma'am.
Yes, ma'am.
So we'll continue with the class. Hope this part was clear to you all. Similar triangle, how we got the 80 values, or shall I discuss once more?
Ma'am,
Yeah. Yes.
that shear stress formula was tau equal to V by A, right?
Yes.
So we have to find V, no?
Hmm. See, now we have
Okay.
to find. Now we have to. In the last class, we found just normal stress and shear stress, right? Now we'll find the. Now we'll find the maximum normal stress and shear stress on the inclined plane. Okay. This is the. This is my cursor is moving clearly. Are you able to see them? See my cursor?
No.
Now?
Uh, yeah, now, yeah.
Yes.
Because
So,
the background is white, the cursor is white, so because confused.
okay, let me change the cursor color then. Let me try to change the cursor color. So now it is visible?
Yeah, I can see pencil, yeah.
Yes. So this is our structural member. This is our structural member. We are applying a uni-axial load P, which is in tension. Okay. And we are finding the normal stress on this plane area. This is the inclined plane. Okay. So we want to find the maximum. We want to find the maximum normal stress. We want to find the maximum normal and shear stress on this inclined plane for for your uni-axial loading. Okay. So basically, this is our we. I want to relate this transverse area and this area, this normal this section and this. I want to relate this section and this section. So simply I am considering two similar triangles. This is transverse area is AT, so I am representing here as AT, and this will be your A. Okay, I am relating this triangle with a similar triangle where the hypotenuse is 1, perpendicular is your cos theta, and this your base is your sine theta. Okay, so if we relate these two similar angles corresponding to A divided by A T. If we equate with the similar triangle corresponding to A, we have our 1 divided by corresponding to AT, we have our cos theta. So, so ultimately we'll get our A equals to AT by cos theta. So this part is clear. Hope this part is clear. A is equal to AT by cos theta.
Yes, ma'am.
Okay. Then let's move to the next slide. Just wait a second. So similarly, what we got, our A is equals to AT by cos theta. Now I want to relate this A to find the normal stress and shear stress on this inclined plane. We found out sigma equals to, sigma is your normal, sigma is your normal stress and n is your normal force. So normal stress is equal to normal force per unit area, if you recall the last class, right? So your n will be how much? It will be simply sigma, sigma, sigma A. So instead of A, what you can write? You have AT by cos theta. So you can write sigma equals to AT by cos theta. See why I want to find this n and v in inclined plane, because I want to relate this n and v with your external load. This is your internal forces, okay? N and v, I want to relate this n and v with P to find the maximum normal and shear stress on this inclined plane. That's why I'm finding this n and v to relate with this external loading. So hope this is clear. We got n equals to sigma AT by cos theta. So I wrote our normal force is your sigma AT by cos theta. Similarly, we can find the shear stress also, shear force also. We know shear stress is equals to shear force per unit area, or we can write V equals to tau into A. So this tau, instead of A, we can write AT cos theta. So we got V equals to tau AT cos theta. Hope this much is clear to you all, how we got shear force and how we got normal force in terms of sigma and tau. Hope this part is clear. Am I audible?
Ma'am, yes, ma'am.
This part is clear?
Yes, ma'am.
Okay. I'm moving to the next part, okay? Okay. So we got our normal force, we got our shear force. Now I want to resolve these components in equilibrium, in perpendicular direction and in parallel direction. This is our perpendicular direction, this is our parallel direction to the cut. So I want to resolve, in equilibrium, this all the perpendicular force will equals to 0 and all the parallel force will equal to 0. Suppose I'm taking the perpendicular. Summation of all the perpendicular forces equals to 0. Now in this section, the perpendicular force is N. So I'm representing here as N. This is P. We have to resolve a perpendicular force. We know by geometry, this will be your perpendicular section with an angle of theta. So this will becomes your, this P will, this for the resultant of this P, this perpendicular force will become your, see the direction is opposite, I'm taking this as positive, so this will be negative. So this will become your P cos theta. P cos theta, and this will be equals to 0. You can write P cos theta equals to N. Okay, you can write P cos theta equals to N, and we know from the last class, from the previous slide, what is your N? What is your N? How much N you got? You got N equals
Sigma AT by cos theta.
Yes, sigma AT by cos theta. So you can write here P equals to P cos theta equals to sigma AT by cos theta. So how much will be your P? How much will be your sigma? Sigma will be equals to this cos theta will go upwards. So P cos square theta by 80.
80.
Yes, yes. This part is clear. How we got sigma equals to P cos square theta by 80.
Ma'am,
Yes, yes,
can you explain that like n minus p cos theta?
yes, I can explain. So see, now we have to resolve this n and v in terms of P. Okay, let me shift to this. We have to resolve this P with this n and v. See, P is in horizontal direction. Okay, let me remove this part. Again I'm annotating. Okay, see, we have to resolve, this is P is in horizontal direction. We have always, we can resolve horizontal into horizontal direction, and now this force is in perpendicular direction. So I have to resolve this component in perpendicular and vertical direction. So for this P, your perpendicular will be, by geometry, will be this, which is making an angle with theta. And for this will be the forces. For this P, this will be the forces with making, which is making an angle theta with this direction. So always the component which is related to T is always, here is your cos theta. Remember, where the angle lies, that component will be your always cos theta, and the perpendicular to the angle will always be your sin theta. This part is clear or not? Which one will be your cos theta and which one will be your sin theta? This part is clear? Hello? Hello?
Yes, ma'am.
Okay. So now, n is your in perpendicular direction and cos theta is your in your perpendicular direction. P cos theta. So this is P now. So this will be your P cos theta. This will be your P sin theta. So I am taking n as positive. You can take any direction. If you are taking this and negative, you can take this and positive. So I am taking, suppose n is positive. N, this is in this direction and this is in this direction. This is in opposite direction. So I am taking minus P cos theta equals to 0. Why 0? I am taking as equilibrium all the forces in perpendicular direction as 0. Equilibrium conditions. Just suppose you take all the horizontal forces is equals to 0. So I am taking all the perpendicular forces equal to 0. So what are the perpendicular forces? In this surface, n is your perpendicular force, and in this surface, your P cos theta is perpendicular direction. So n minus P cos theta equals to 0. Till here understood? Hello? This one is clear?
Yes, ma'am.
Okay. So you can write
Yes, ma'am.
P cos theta here. You can write n as this side. Now we know n is your how much? Sigma 80 by cos theta. So put the value of n sigma 80 cos theta, and P cos theta is here. So you'll get sigma equals to P cos square theta by 80. Am I correct?
Yes, ma'am.
Hope this part is clear. Everyone, hope this part is clear. Sigma is equal to your P cos square theta by 80. Clear? Everyone? Only one student is replying. What about others? All are sleeping? Huh? Understood or not?
Yes, ma'am.
Okay. So we have resolved this part. Now we'll resolve the parallel forces. Okay. So so this shear force is parallel in this direction, and this P sin theta is parallel in this direction. Both are in opposite direction. So suppose I am taking P sin theta as summation in parallel direction as F. Summation of forces in parallel direction is taking as 0. So P sin theta minus V. Okay, you don't think that I cannot take P sin theta in negative side. I can take. Then I have to consider it as this V. I'm taking this as positive, so I have to take this as negative. minus sin theta minus p sin theta. I can take that this way also. There is no option to erase. This is the eraser, I guess. Okay. So summation of all the parallel forces I'm taking as 0. So I have taken p sin theta as positive. So this is in another direction. So this will be negative. So p sin theta minus v equals to 0. And I'm taking this minus v to this side, which is v. And we know what is the shear force. It is tau at by cos theta. So this is your tau at by cos theta. So again, your tau will be p by at sin theta by cos theta. And from the trigonometric, you know what is sin theta? Sin theta into cos theta is how much? It is equals to your half sin theta by 2 theta. If you go back to your trigonometric classes or maths classes, you will get this formula. Your sin theta by cos theta is equals to half sin theta. Half sin 2 theta, sorry. Half sin 2 theta. So we can write, so so we'll get tau equals to p by twice at sin 2 theta. So you understood the relation between normal stress and shear stress with the external uniaxial loading. Those two derivation is clear. Hello, hope this two derivation is clear to you all.
Ma'am,
Yes,
that P sin theta equal to V and
minus.
equal to tau 8, that line.
Okay, this line. Okay, let me erase.
Yeah.
Let me erase again. Okay. So we have resolved the perpendicular forces over. Now we'll resolve the parallel forces. So this is one parallel forces in this direction V, and I told you there will be another here one component which is P sin theta. Okay, this is in this direction, this is in this direction. So I'm taking all the parallel force summation of all the parallel forces equals to 0. Summation of all the parallel forces equal to 0. So suppose I'm taking P sin theta positive. So P sin theta, this is in upper direction positive, minus, because this is in another direction, downward direction. So V equals to 0. Now P sin theta can be equals to V. Here it was in negative sign. If I take it to this side, so it will become V. And we know what is the value of V? Tau at by cos theta. So simply put, P sin theta equals to tau.
Yeah, I get it now, ma'am.
Yes, tau at by cos theta. Now if you want to find the tau, so it will become P sin theta cos theta divided by 80.
80.
Yes. And by the trigonometric, sin theta into cos theta is your nothing but half sin 2 theta. So your tau will become P sin 2 theta divided by twice of 80. Clear? Your tau is P twice 80
Yes, ma'am.
sin 2 theta, and your sigma was how much? Sigma was, I think, P80 cos square theta, like that.
Mm.
So your sigma was P80 cos square theta 280 Sin 2 theta is your shear stress. Now we,
Correct.
yes. Now we got the sigma and now we got the normal stress and shear stress. Now you have to find when these two values will be maximum. Okay, when the normal stress will be maximum and when the shear stress is maximum. You just have found a formula ki this will be the normal stress and this will be the shear stress on the inclined plane. Now you have to find when this value will be maximum. Okay, so by seeing the formula, just tell me when this values can be maximum, when the sigma can be maximum, on what value this will depend. Just try a guess.
Theta.
Yes, theta.
Theta, cos
Yes, exactly. This will depend on the theta. Okay. So
angle.
when the cos theta is maximum, any idea? When your cos theta is usually used to be maximum?
For-
Cos has to be
45.
1.
Cos,
So it's
yeah.
cos 0.
Yes, exactly. So if we see the function of cos, if we see the function of cos curve, it is like somewhat this, right? This is your 0 angle, this will be your 90 degree, will be your 180 degree, right? So when the cos theta is maximum, it is in 0 degree in
0.
upper direction and in downward direction it is 180 degree, right? So your sigma will be maximum. You can write, I forgot to write here. So your sigma will be maximum at theta equals to, or if theta is equals to 0 degree
0.
and 180 degree. Clear this part? This part is
Yes.
clear.
Okay, ma'am.
So your sigma is your maximum when your theta is equal to 0 degree and 180 degree. Now come to the tau.
Ma'am, when it's 180 degree, will it be negative?
Yeah, it will be negative.
Hello?
Yes. So these two are the things when the your sigma will be maximum value. Next, come to the sine function. How the when the sine theta is maximum? Remember the
90.
90. Yes, good. 90, and suppose this is your sine function. How is the curve works? It is like this and this. So it is maximum at 90 degree. This will be your 270 degree. Now see, the catch is here. The theta is your 2 theta. 2 theta 90 degree. So what will be your theta? Definitely it will be 45 degree or not? Am I clear?
Yeah. Yes, ma'am.
Sorry for the inconvenience. Okay, just a second. Okay, so understood the so your theta, this for tau max, your tau will be maximum when the theta is your 45 degree. So 90, half of 90 is your 45 degree, and we got 270 also. The half of 270 is your 135 degree. So these two are the theta value when the tau will be max. Okay, understood? Clear?
Okay, ma'am.
Mm.
Yes, ma'am.
Now there is an important point. The sign of shear stress changes when theta becomes greater than 90 degree. Okay, so when the theta is less than 90 degree, your direction of shear stress is this way. Okay, but when the angle becomes more, so it changes the direction in this direction. Normal will be the same, perpendicular to the cut surface, but shear stress will change. Remember this point. The sign of shear stress changes if theta becomes more than 90 degree. Okay, if less than 90 degree, this will be the direction, and if more than 90 degree, this will be the direction. Now here comes the important part of the lecture. Just tell me what will be the magnitude of sigma max. What will be the magnitude of sigma max? Hmm? what will be the magnitude of sigma max? Suppose if I put cos theta equal to 0, what will be the value? P by A? Yes
P
or
by
no?
80.
P by 80, yes. And
Yes,
Yes,
ma'am.
ma'am.
what will be the value of tau?
Under root.
Under root or twice
No, P by 280.
P by twice of 80. So it will be, sure, P by twice of 80. Okay, this is your homework. Find out what will be the answer. Okay, magnitude of sigma max equals to how much? And how? You find out. Okay. So next move to. So this is the problem. Still students are coming, waiting in the. Hope you have understood what I have taught in this class.
Yes, ma'am.
Yes, ma'am.
Okay. So go with this. This is your worksheet problem. For a simple model of the engineering structure shown in the bar, BE is a 50 mm diameter. This is your BE, which is, just try it once, okay? This is BE is a 50 mm diameter round steel bar. You can neglect the weight of this individual member, okay? For a transverse cut of the bar, find the normal stress in the member BE. For this member, you need to find the normal stress. And for a non-transverse cut of the bar at an angle of 30 degree, find the normal stress and the shear stress in the member. Kindly write this question and this figure in your copy and try to solve this numerical. I won't discuss the solution of this part today. I want this one as an assignment, or I'll do one thing. I'll upload this sheet in your ERP. You'll get an assignment. You have to submit it next Monday. Next Monday will be too far. When I have next class with you all? On Wednesday? Hello? Hello?
I'm checking.
Wednesday, na? But ERP process. Okay.
Ma'am, Wednesday, 11:15.
11:15. Okay, submit me on Friday. Okay, submit me on Friday. I'll upload today itself in the ERPs, as this will be your assignment 1. Please submit your assignments because all will be calculated.
Ma'am, can you explain the question?
Yes.
Like what we actually have to find?
Okay. So basically this is your bar. Okay. This is your structure. The B, this is your member. The bar B is this member is given to you. Its dimension is given to you, 50 mm diameter round steel bar. Okay. Its dimension is given. For a transverse cut of the bar, means if we cut this bar, what will be the normal stress in this bar? And if in non-transverse, if we cut in the inclined plane at an angle of 30 degree, if your theta is 30 degree, if we cut the, let's show the previous slide. See, for the, suppose this is the, consider this is your bar BE. If we cut that part, what will be your normal stress? If we cut that part in an angle 30 degree, what will be your weight? What will be the, you have to find the normal stress and the shear stress in the member BE. Don't get confused with the whole structure. Just you have been, remember, I have given a truss, I have taken out a member, then I have cut that member. How this member came? We have taken out a member from the truss member or not? Simply they have given you a structure. They have asked you to find out the normal stresses on this member only. Okay. For this member you have, if you cut this, suppose just wait a second. Let me note. If I take as a BE, suppose this is your BE, is a structural member. Dimension is given to you. It's a round steel bar which is 50 mm dia. So if you cut a transverse cut, what will be the normal stress in the member BE? They are asking you to find. And if you do a non-transverse cut, making an angle 30 degree with the structure, just try once. Find the normal stress and the shear stress in this member BE. Hope I'm clear with the question.
Okay, ma'am.
Okay, forget about the ERP. Just forget about the ERP. For the next class, Wednesday, just tell me the answers. Okay? And I'll give a chance who can share their screen also. Forget about the assignment, first assignment. I'm leaving it. Might be a difficult for some of some it might be a difficult for some students. So let it be. Just try it in just try it once and tell me the answers. Okay? We'll give another assignment for the ERP. So hope today's class was clear to you all, crystal clear. I'm stop sharing my screen. Okay, just quickly tell me your attendance. Roll number 1.
Yes, ma'am.
Number 2.
Yes, ma'am.
3. Abrisha. Arbisha. 4.
Yes, ma'am.
5. 6. 7.
Yes, ma'am.
8. 9. 10. 11. 12.
Yes, ma'am.
11 or 12.
11.
12. 13.
Yes, ma'am.
14. 15. 16. 17. 18.
Yes, ma'am.
19.
Yes, ma'am.
20.
Present, ma'am.
21.
Ma'am.
22.
Need to.
24.
Yes, ma'am.
25.
Present, ma'am.
26.
26 present.
27. 'Okay, do one thing, write your roll number in the chat box.